All right, so solving inequalities is almost identical to the process that we do for solving equalities, except the very last step. There's one additional thing you have to think about when you are doing your very last step. Can we lose the earbuds? Thanks. Okay. You will also be graphing your answer on this number line. Now, one thing about the number line that's given to you is that, well, if you come up with an answer that's anywhere near the values that are on your number line, that's a pretty good indicator that you made a mistake somewhere. Okay? So if your answer comes out to be -4, we have a problem. Okay, and you might want to go back and look at it again. Okay. All right. So let's do this one. The process, like I said, is the same. You're going to draw that line. Now, distribute, right? This left-hand side, what happens to him? Anything? No, because there's no distribution there at all. 6 times x, 6x. 6 times -4, -24. All right. Now, we're going to rearrange as we always have. 5x, stay or go. -17, stay or go. Goes. Comes over to the other side and becomes a positive. 6x, stay or go. Goes. Comes over and becomes a -24. Good. Combine my like terms. 5 minus 6?
No, it's -1x.
-1, right. -1x. And 17 minus 24. Well, what's 24 minus 17? Right, 7. Excellent. But this one, the 24 is negative, so my answer is going to be -7. Okay. At this point, everything has been exactly the same as we have always done, right? No different. The only difference now is that when I divide, if the thing I divide, that -1, if that coefficient in front of my x is negative, then that symbol gets switched. Okay? If that was a positive 1, or a positive whatever, you wouldn't flip it. You would just divide. Okay? Only when you divide by a negative do you switch the symbol. So, we divide by -1, and we switch the symbol. And what's -7 divided by -1? Plain old 7. X is less than 7. Now, for your symbols, if you do the math the way we've always talked about, where variables are on the left-hand side, okay, then that symbol will look like your graph. We're going to start at 7. And if we look at this symbol, the less than symbol, that's what my graph is going to look like. Now, there are two kinds of inequality symbols, one with a bar and one without a bar. Neither one of them have earbuds. Thanks. Okay. If I had okay, the way to tell how to graph these is that this symbol uses less ink or less pencil than this one, right? Doesn't have the bar under it. Uses less pencil. This uses less pencil than that. It's the only way I remembered when I was a little kid. Okay? Yeah. If you have a bar, you're going to fill it in. More ink is more ink. Less ink is less ink. Okay? And if you keep your X on the left, then your symbol will look like your arrow. It will point in the same direction. So for example, if we had instead x is greater than 7, my graph would look like that. Because what we're saying is that things that are bigger than 7 are part of my answer. Like, for example, if x was 10, is 10 bigger than 7?
Yes.
Yes. So that means that that's a true statement. That's valid. I could plug it in and not be lying. Okay. And if you'll notice, 10 would be here, and this arrow goes on forever. So all of these numbers going on and on and on forever, if I were to plug any of them in, I would get a true statement. If I plugged in 1,000,000 for x, it would still be true. But if I plugged in 7, is 7 greater than 7? No, and that's why we put the dot there. It's a hole. It's a missing number. It doesn't belong there, okay? If it was filled in, we would say, yes, 7 is good, like now. Now we're saying 7, that point, boom, is allowed, because if I plug in 7, 7 is greater than or equal to 7, and that's true. You see? So that's why we have a filled-in circle, because if we're saying it's included, it's a point. But if we have a circle, we're saying, no, it's empty there. It doesn't include it. It's missing. Okay? How would I write, if I were to give you and ask you what you mean, what would you say? Just a second. Somebody over here. How would I write that as symbols? Numbers and symbols. Jeremiah. Less than, I'm sorry? You could say or equal to. That's what I think you. Right. You got it, exactly. X is less than or equal to. That bar is in there. And he knows that the bar is in there because it's filled in. This symbol took more ink. That symbol takes more ink. And the number is -4. Okay? Now, by the way, you won't be seeing any of these today, but just to let you know how to deal with it, if, by example, first somewhere along the line, you came up with this, okay, where x is on the wrong side, okay, you just flip everybody around, okay, because what you're saying is x's that are smaller than 3. 3 is bigger than x. You see how if you were to read that? Okay? So x smaller than 3. These are the same. Okay? What's that? They're worded differently. It's kind of like saying, you know, you know, two different ways of saying it. It's like, you know, you're a student at Stonewall Jackson High School, and you are a Raider. Okay, if you're a Raider, then you are a Stonewall Jackson student. Two different things to say. One is one version of a definition. The other one is the other. Okay, so how about this? Why don't you guys try this one on your own, and we shall see how it goes. By the way, if your problem started out with a bar, then your answer is going to have a bar. Your symbol can get flipped left and right, back and forward, but you can't lose the bar or create the bar. Okay? So don't add it in there or take it away. It's important. Okay? So take a second and go ahead and graph and do that, and then I will give you a graph for it, and you should draw your graph. So like I said, your answer had better be somewhere in the neighborhood in -5 to 1. And if it isn't, then something's silly, something's wrong. Okay, so let's burn our way through this guy. I understand. Hold on, there's some questions. I'll get to it. I'll get to all y'all in a second. So 3 times 6 and 3 times 2. Good. Okay, now let's rearrange everybody. 18x, stay or go? Stays right there. Positive 6, stay or go? Goes and becomes a... No, not x, just negative 6, right? Okay. It's negative 8x. Is in the right place? Comes on over and becomes a negative 20. Stays. And now we combine. Okay, now, I said it at the get-go that when you divide, if the thing that goes underneath the coefficient in front of the x is negative, then it flips. Right now, that 26 on the left, that's a positive number. Okay? So when it's positive, nothing flips. I don't care if the right-hand side is negative. Okay? That doesn't matter. It's just this guy. This is the only thing that I'm talking about. That's the thing that matters. Okay? Not the right. Okay? So since this is a positive number, it doesn't do anything to the symbol. Okay? And we get x. What's negative 6 divided by 26? Negative 1. So, does this have a circle or a dot?
Dot.
Which one is it? It's filled in, right? It's a dot. It's not a circle. It's got more ink. Okay, it's filled in. So we put a negative 1 and we fill it in. What direction does the arrow point? Correct. It looks like this guy's arrow, right? It goes like that. Okay? We cool? It's really a lot like the other stuff, except the very last step. If the very last step is negative, or dividing by a negative, then yes, then we flip, but that's all. Question? Yeah, go ahead. Here. All right, you want to do one more? You ready to hit the boards? Hit the boards? All right. This episode of the Ronco Show has been brought to you by the less than and equal to symbol.